This week's Swarf and Chips comes from Milltech in Norwich. I've got a brilliant show lined up today. Once again, a UK manufacturer who's embracing automation. Now, last week we saw Lindsay at High Spec Engineering, and today on a similar theme, I'm once again at one of East Anglia's largest and most successful manufacturing companies. This is Milltech Precision Engineering. Welcome to this week's Swarf and Chips. So coming up today, we look at 3 machining processes, all of which have been improved no end thanks to automation. And we start with the installation of Matsura's HBUS 300 cells, the first of which was installed in 2014. So Mark, we start here today in front of this HBUS 300 from Matsura. The journey that your company's gone through in recent years has been quite incredible since the last time I was here, maybe 5-6 years ago. Investment in automation, and that's the big topic in today's Swarf and Chips show. Let's start with this machine and look at these parts that you're doing on here, because these are of real interest to me, because previously you would have done them on normal standard VMCs, wouldn't you?
Correct.
What's the difference between running them on a machine like this from Matsura?
I mean, the obvious one is the reduced number of operations. So yeah, running them on a standard vertical machine, you've got multiple ops, 4, 5, 6 ops sometimes. When you can bring them over onto Matsura, you can reduce that down into 2, 3 ops. Which is really reducing man time in it as well.
And so previously on your VMC then, would you have had all op 1s on one machine and then op 2s on another machine, or would you have moved them through the operating process on one machine?
It could vary depending on what we needed out of the product, but quite often we'd keep them on the same machine, run all op 1, come back, run all op 2s and stuff.
So let's just maybe pick on the bigger one of these two.
Yep.
Can you maybe just talk us through what it is and what it's made from, and where it would end up?
Yeah, so these are all for the gas and oil industry. They're all valve bodies or manifold bodies, made from 316, which is pretty much everything that we run through here, which is a stainless. We can run other materials through there as well, but this is all predominantly 316.
And are they quite tied up, these components? Is it quite important to be able to do them in lesser operations to take the risk out?
Yeah, absolutely. So the tolerance on the parts are really tight, and the repetition of these type of machines means that you get really good quality very repetitively actually.
So how many pallets have you got on this particular machine, and how many tools? And what does that give you as a company when trying to produce a variety, because there is lots of different ones, of components like we see here?
So the machines are 15 pallets and we have 180 tools, but we don't ever really maximise that out. I think we probably have about 150, 160 in there at any one time, giving us a little bit of scope for changing. But even that's potentially too many, but what that allows us to do is run sister tooling. So any tools that break come to end of their life, it can move on to allow for that 24/7 running. But that also allows us to run both parts at the same time or in the same set. So this could be on pallet 1, this could be on pallet 2, and you could run them lights out 24/7.
And would there be an effect if you did keep the machine running with it growing the heat that the spindle's generating, maybe, to affect the tolerances of the final parts? Or do you find that the machines manage to maintain precision?
Absolutely, they maintain precision. They're built in to give themselves the kind of coolant and the rest time that they need to maintain the tools. I mean, everything comes with a prescribed tool life. All that data is entered in as we load different tools, and then they kind of manage themselves really. All we have to do is physically change the tools when they do get to the end of life.
The big part here and the big topic today is about the automation, and I want to find out in real time what the impact has been. And you've managed to assess that recently thanks to Matsura's RIMS software, haven't you? Can you maybe just give us a very quick overview of some of the results you've seen using that monitoring as to how productive this cell is now for you?
Yeah, correct. So we've brought in an actual data analyst as well to help us really look at the data that the RIMS software has given us. We're very much comparing that to what was and what we've got now, and really drastically reducing man hours. The comparison is huge.
Okay, and in a percentage terms, do you think these machines now are running over 90% efficiently then? Do you think that spindle is going for 90% of time.
It is. In fact, we're slightly better than that, we think, at the moment as well. We're trying to push towards 92, 93%. But yeah, I think 90% is.
And you wouldn't be able
fair.
to assess that unless you had this data then, I assume?
Absolutely not, absolutely not. I mean, it's vital to know what you're doing. I mean, the part comes off at the end, which is great, but to be able to have all of the data, then you can do what you want with it as a company and shape future decisions. It's fantastic.
So it's clear to see that savings aren't just to be made on the hardware. The software there, the RIM software has had a massive impact on increasing productivity too. Now next up, we're still on milling, this time 5-axis machining. I'm standing in front of this DMG Mori machine, 5-axis machine, DMU40 Evo. The production gains and the savings, once again, have been truly phenomenal, as we find out as we talk to Aidan. So Aidan, I've moved now into your other machine shop.
Yep.
Much bigger, many more spindles in here.
Yes, definitely.
But what we see here is this DMG Mori DMU40 Evo with the PH150 pallet system. Now, in principle, what you're trying to do with this machine is similar to what we've just seen to keep that spindle running, isn't it? And replace some of the work that the 3-axis machines do. From your experience hands-on, you've used the 3-axis machines in the shop, single table machines compared to this. What do you think the biggest difference is?
Time saving is phenomenal. I came off the 3-axis onto here, and it's unbelievably quick. The setting time is reduced, your run time due to spindle speed and everything else, it could be so much quicker.
Right, there's 2 areas to where this machine has had an impact, or this cell, should we call it, has had an impact. And in fact, if you could pick up the larger one of those parts there. Now, firstly, you used to do this again in the 3-axis environment, didn't you, on the machining centres? How many operations would have been involved in that?
So this typically is one of our valve bodies. That would be, you're looking at least 5 operations on this. You come onto this machine and you can do every single face and a skim off the back. So you're looking at 2 ops.
Okay, now this is a 5-axis machine,
yes,
importantly
it is, yeah.
to say. So the biggest saving is the setting time. Whereas, how long would it might have taken you to set from one operation to another? You've got to position it, you've got to clock it up. How does it work?
If you were to do it vertically, you could potentially look at anything up to 2 hours a face. Depending on the features you've got there. I mean, you've got quite a few features on some of the faces compared to the others. So realistically, if you're looking at 2 hours a face, it adds up considerably. Whereas on somewhere like this, you could maybe set that repeated features maybe in about 4 hours max.
Okay.
So it's a massive time saving.
So you've got the advantage in the setting time, but then of course comes the machining cycle. What have you done, or what can this machine do that your others couldn't in this area that make the actual machining time quicker too?
Well, this machine's got a higher RPM on the spindle. It's got a lot more powerful through spindle coolant, so we're able to use longer series carbide drills, a lot smaller carbide drills as well, allow us to machine harder and faster and more efficiently. Especially on materials like aluminium, it means we can really hit it.
Because we've been looking at some of your other bodies which are stainless, but you're doing aluminium on here. But would you do some of the stainless work?
Oh yeah, we do.
Too?
A lot of our valves are stainless, so it is. The majority of this machine is stainless, but it is impact on aluminium as well.
So altogether, taking into account those 2 factors, the setting and the machining, how much faster is one of these getting through your production now compared to what it was maybe 3 years ago before you had this machine?
I would say at least 40 to 50% faster, easily.
Okay. So automation, in your opinion then, as a programmer, setter, operator of this machine, how much difference does it make to this company, do you think?
I think it makes a tremendous amount of difference. I mean, I could be setting on here a smaller batch during the day, maybe a 4 or 5 off. Like this, for example, you're doing all the ops in one go and then doing the back. And then I could have a larger batch, like a 300 batch set as well. For when I go home, the shift workers come in and it'll just run all night on that larger batch. So it never stops.
One thing I think people do overlook a lot is the responsibility of a machinist.
Definitely,
with expensive componentry. When you're moving them around from machine to machine, there's a risk every time you move it from op to op, isn't there? Which do you feel more reassured with technology like this, that those risks are kind of dissipated, gone, or eliminated?
Especially when we work with tight finishes as well. So having every face done on here, every port done on here is it's a lot of reassurance, because then you haven't got the risk of people moving it about, knocking things. It just comes off the machine, near enough complete. It can go set aside and not be damaged. So it's really a relief, really.
Is there a fight to use this?
Definitely, yeah.
Before we move on to our final piece, you're probably thinking, now this is some company. Well, you'd be right. They've invested over 2 million in automation since 2014, and the company was also purchased by the Indutrade Group in 2015, which further advanced their offering to industry. Now employing over 50 people, operating out of 2 sites, the company has just passed its 25th anniversary. The disciplines they offer here include what you've seen, plus 3 and 4 axis milling, CNC sawing, sliding head turning, Kanban solutions and multi-axis fixed head CNC turning, which is what we look at next. Ian, with automation comes flexibility. We move on to our third piece now, which we're going to look in detail at this MAZAK HQR 200 MSY.
Yes.
And some of those areas that flexibility really comes into play. Now, could you maybe just explain to start with what this machine is in terms of turrets and spindles and so forth?
Yeah. Basically, this machine is a turning centre, so it's not just a standard lathe, it has the ability to mill. This machine has 2 turrets, top and bottom turrets, both with full Y-axis, C-axis on the spindles, and both turrets have the ability to have 16-station live tooling. So the flexibility for this machine compared to some of our other lathes is phenomenal, really, what it can do.
So it's an automation cell in itself. It's fed by a hydrofeed bar feed unit
yes.
that we have here. You've got 2 parts in your hand,
yes.
and we're going to pick on this part in your left hand to start with, because this is a component. You couldn't do this in the same way on your other machines as you can on this. This machine has got the flexibility and the tool capacity to do this, hasn't it? Can you explain?
Oh, definitely, yes. So this is a medical company came to us with a particular problem, basically with what's going on at the moment, in that they needed to increase the capacity within the wards. So they redesigned a component which basically went from 1 oxygen branch to 2. So they came to us to see, obviously, if we could help them to manufacture the components. With a typical part like this, if you look at the ports that's on there, there's 3 different ports around it, as well as you've got engraving on the end there. Obviously, the ability of this machine, with having the amount of live tooling and the twin turrets, gave us the option to actually load up the machine to be able to machine something like this in around about 10 minutes because of the capabilities of the machine.
Okay, now whereas on your other machines you may not have had enough tools. I think you said you needed 14 tools on one.
I'd say roughly about 14 tools, possibly 15, to actually machine this component, where our other machines, the maximum we have is 12 station turrets. Not only that as well, is the only other machine we have with a twin spindle has only a very small indexer. So in other words, when you try to machine the second side of the component, it can only pulse round, where this machine, because it's a full C-axis, gives you the ability to actually machine in a continuous movement, which is what we needed for this type of component.
So the HQR then, as a machine, this is almost like 2 machines, isn't it, in one, where
definitely
identical on both sides, that bigger carousel on the turret, or that bigger tool capacity, the Y-axis and the C-axis on the spindle.
It
2
is.
machines in one.
The other benefit from this machine compared to other twin spindle machines we've got, with the twin turret, it runs fully independent. So it's like 2 machines in one, where you can run both spindles at exactly the same time, doing completely different processes with milling, which we can't do on any other machine.
Okay, now I'm going to take that one off you.
Yep.
If you can then let's show us this other part, because this is really fascinating here. We're looking at this, and I looked at this and I thought to myself, why wouldn't you make this out of tube? But there's a good reason not, isn't there?
Yeah.
And it's made out of bar, basically.
It's made out of solid bar. The reason why we haven't made it out of tube, we tried tube, but the problem is getting tubes in the right sizes. The properties of tubes as well, machine completely different to solid. And actually, to stick a U-drill and to machine this out of solid doesn't take very long at all in comparison to the cost of the tube. And actually, we were able to get a better finish making this out of a solid than we would do out of a tube.
Okay, now I don't want to get away from the fact that we're talking about automation here, because it's really what this show is about this week. This machine enabled you to run these in quantities in an automated fashion, didn't it?
Definitely.
Even with the work holding that you use, because I'm thinking, how do you grip something like that once you've done the U-drilling operation? Maybe explain how all that works.
Yeah, I mean, obviously with a part like this is all to do with aesthetics. So it's all about what the part looks like, as opposed to, so long as it's within a drawing spec, everything's good. So with something like this, correct its own issues. So to manufacture something like this and still maintain the surface finish on the outside, we actually got a long series set of jaws to hold internally. So we feed the part in on a bar, through the bar feeder, machined, drilled a hole in it, machined obviously the ports around the outside, and then actually fed it through to another set of jaws on the second spindle to be able to hold it internally so we didn't damage any of the outsides. We can then machine, as you can see, the drilled and tapped hole in the other side, and then when it's finished, we have an unloading arm now which comes down, we'll grab the part, slide it out of the jaws, will come up, and then it'll drop it on a conveyor and it'll roll down the end of the machine.
And what about the damaging of it when it's coming out on the conveyor? How do you protect against that as well?
Well, obviously what you have to do is try and look at the best methods to try and minimise any kind of damage. Obviously we filled up the unloading hopper at the end with a lot of bubble wrap to make it nice and soft. Obviously we minimise the amount of parts that obviously get unloaded at one time. Obviously we'll have one of the loaders come up, they'll periodically take the parts out so there isn't a big amount of parts and they're banging against each other. And when you run a job like this, it's about just keeping on top of it. The machine runs, but you just keep on and unload it and make sure that everything aesthetically and obviously dimensionally is correct.
And once again, it's not cost effective to run this job without automation, is it? It just wouldn't work.
It isn't, no. When you're talking about making these in batches of 1,000, if you have to keep going up to the machine, open the door, unload the part, you lose time. Somebody could be busy doing something else. It's all time wasted in the machine sitting there doing nothing. So automation is the key.
Michael mentioned to me, and this is where we're going to close this one off, about this being like a vending machine as well, like the other two solutions that we've looked at. The amount of tools you can have, you've got a preset amount of tools on there, haven't you? Which basically allows you to go from job to job pretty quickly. Is that the advantage of this technology too?
Absolutely. I mean, we talked about automation. On this particular, what we've got running on this machine at the moment, we're only using one spindle, but because we're doing a variety of jobs at the same time, we have the ability to load both the turrets up with more tools than we would do on any other machine. So we've probably got about 20 tools set in this machine, and that gives us the ability to be able to just load a program, hit the button, run a part, load another program, because all the tools have been set for all the jobs simultaneously. So we could probably run 10, 15 jobs that use the same tooling, but only because this machine has the capabilities of doing that. We couldn't do it on any other machine. That's why we've not used the twin spindles, we've used one spindle, but we've used the two turrets to get that extra productivity out of the machine.
So that's it for another Swarf & Chip show. As always, thanks to our sponsors, Interco. For specialist exotic materials, contact them. Now, UK manufacturing is changing. Companies are learning that automation is not just about long runs. It's about flexible, reliable manufacture. It's about keeping the spindle going even when the lights are out. Now, big thanks to the guys here at Milltech. The automation is enabling them to run Kanban solutions for their customers, which means they can call off product as and when they need it without having to hold stock themselves. In this instance, everyone is a winner.